Hello Internet, welcome back to our asteroid belt. In this video we are going to be focusing on pooling all of our asteroids. Last time we made it so that we could actually create asteroids as they got near. So instead of using an instanced version, we'd actually use a real physical game object, and we'd be able to use that so that it could simulate physics and do all sorts of other fun stuff. Now what we want is we want to create all of those at the start and then just recycle them over time. So the advantage of that is instead of constantly harassing your garbage or your memory and constantly allocating new things and then making your garbage collector clean it up, we're going to allocate it once and then just keep it there and reuse it. And so the advantage of that is it prevents you doing really expensive operations that you don't need to do. So destroying and creating objects, and especially garbage collection, those are really, really intense tasks, and we don't want to do those if we don't have to. And so this is going to make it so we can actually avoid doing that. Especially when we have 1,000 things that we're constantly creating every frame. It becomes really important, especially like here it's a little bit less. We can still get a decent frame rate. If you're making like a bullet hell, this is almost a necessity. You almost have to do this, otherwise it's just going to be way too slow. So we're gonna get started. I'm gonna show you what I have, and then we'll actually get onto it. So here's what we have right now. If I turn on the gizmos, you can see the nearby asteroids have colliders and are actual game objects. I have to kill this quickly because otherwise Unity crashes. That's also one of the things I'm hoping to fix. There's some sort of weird out of memory or bad memory access that Unity is doing that's causing it to crash, and I don't know what's causing that. It's not anything we've done to my knowledge. So we're gonna move on and pretend like it's fine. What we need to do right now is we have this generic object pool. There's nothing here. I haven't done anything with this. We're gonna make this store all of our objects, and then you're going to call this, instead of calling the default instantiate and destroy, you're going to call this, and this is just going to have a list of invalid objects. So the way we're going to do this is we're just going to store game objects. We'll just give it a prefab. So this is I'm designing this so that this can work in any project. Hopefully it actually does. I don't honestly know. It'll work for this one, that I can assure that, and the design is such that it shouldn't be too much overhead to get it working anywhere. So I'm also going to stick a game object array behind this and call it our instances, and a private int, and we're going to call this our last selected. So this is going to be our starting point. It's going to be the last object we created. And so the reason we're doing this is because theoretically, the next object after this should be available. You should be able to select it. Or at least if you're doing things sequentially, if everything's happening perfectly sequentially, it should be nearby. So what we're trying to do here is actually speed things along a bit. So we're actually going to make a circular queue, and we're going to revolve around it until we get back to this index, and then that's going to be our endpoint. And we'll start at last selected plus 1 and just wrap around. So hopefully that kind of speeds things up. It might be premature optimization. I'm not sure. But I was reading over a bunch of different ways. People suggested stacks or queues or a number of other things. This seems like a good solution to it. And if it doesn't work, then we can try something else. So we've got our prefab here. We're going to create a ton of these. So the question is, do we want to initialize it here? Or do we want something else to initialize it? Something that's going to use this to initialize it? I think the best idea, we'll give it a count. And so the idea here is we'll give it an instances is going to equal a new game object array of size count. And then for int I from 0 to our count, we're going to want to initialize those game objects. So this should be easy. All we need to do is create a prefab for each of those. So I'm going to create a instance. We'll just store it there, and then we'll instantiate. Ooh, that's not right. Instantiate a prefab. And we don't care about anything else. Nothing else has to happen here. The only thing I do want to do is actually disable this. So we're going to set active to false. And so this just disables it. It's the same thing as going into here and clicking this check mark and turning the object off. So when it's inactive, when its active state is false, it doesn't update, it doesn't do anything. So that's sort of the default we're done here state. So next step, transform.parent. This way everything just stays neat. We'll set the transform.parent to ourselves. That way they'll all be parented. And we should actually, if I just disable this instance asteroid render, we should be able to start this and get, well, 0. So that wasn't very helpful. If I make it 5, we should get 5 instances, and they should all be disabled, so nothing should be happening. Yeah, so we get 5 disabled asteroid clones. And so we've got our pool. Now what we need to do is actually find them. So we can get rid of this update. That's not really needed. But we do need a way to actually get an object, which, what if we just call it next? No, we'll keep the same terminology. I think that makes the most sense. So we're going to give it a vector3 for our position. Something's loading. There we go. And then a quaternion, and that we can just give it as a rotation. So this should be the same message. It should be the same signature that you do if you normally called instantiate. You just don't pass in the game object type. So the idea here is you would create a separate pool for each type of object you wanted. So in this case, every single asteroid type is going to have a separate pool that we'll pull from. And as long as you have access to that pool, you'll be able to actually pull out instances of it. So this is the hard part. Well, there's 2 hard parts. Then we need a void destroy, and we're going to destroy a game object. So I don't know of a good way to make our destroy not linear time. I've been trying to think of this, and the best I can come up with, I think this is the reason people were suggesting like stacks and things, because that's constant time. But with this, all we have to do is find our instance in our instances and disable it. So for int I from 0 to our count, let's use our instances count, because our actual count may change over time, which isn't ideal. That shouldn't happen, but because it is public, it could change. So in the case that it does, this count is updated after start has been called, we're going to rely on our private variables until you restart it. So the next step, we need to actually destroy this. So we're doing a search over this entire list. We could use link here, but I think link will be slower. And what we're really trying to get here is speed. So instead of using like a where, we're actually going to find the thing. So we could have used a for each. That would have worked as well. But if our instances I is equal to our game object, the one we're destroying, then instances I, actually, no, we don't need to do this. And the reason we don't need to do this is because our game object is going to be a reference value. It's a class, so it'll be a reference. If we give out the game object, everybody that references it is going to be accessing the same one in this queue, which is important because this means we can just set active here to false. So now that I think about that, this will set the reference, or the game object that has that reference, it'll make it inactive. So we don't actually need to do a search because we already have the reference to it. We just need to disable it. And this allows us to do that. And that should be much faster. Cool. I like that. That's nice. I don't know why I didn't think about that. I've been thinking about this for a few days because I knew we needed to do it, but I didn't really want to do it. Like, there's a number of pools out there, and people, if you look on like the Unity asset store, there's hundreds of pools that people have made, and they've all done it a little bit differently. So I've been kind of trying to think of what's the best way to do it. Never really came to a conclusion, so I just figured let's do it. But yeah, I thought let's think of something. Anyway, I got distracted. What we need to do here is search for an object that is not active. So the way to do that is we're going to start at our int I is going to be equal to our last selected. That's going to be the index of the last item we selected. So the idea here is we are assuming that the last item that was selected was not immediately destroyed. If that's going to happen a lot, if you remove this +1, you'll select that last object, and that might give you a bit of benefit. I don't think that's going to happen, so we're not going to use that. So if I is equal to our last select, or if I is not equal to our last selected, now that I think about this, how are we going to actually do that? Because we want to circularly do this. It becomes easy if we do that. No, it doesn't. What am I thinking? Still not easy. Good question. I'll write it and then I'll think about it. So we want to increment I, but we're going to do it a little bit differently. So I is going to equal to I plus 1, and then we're going to mod by our instances.length. And so what mod is going to do, it's going to get us the remainder of the division, which is going to divide by the length of it. So if we would wrap off of our, if we would go all off words, if you would go off your array, it'll wrap you around to the beginning, and you'll get back. So that should kind of do the circular motion. The logic here is wrong. So it's going to be grayed out because ReSharper is saying, hey, this isn't going to do anything. I know it's not going to do anything. We'll fix it. Maybe. Oh, it's saying it's empty. Never mind. Different issue. So if our instances I is not, we actually want to check the active self. So if it is active, then we're going to ignore it. So if it's not active, switch that to a not, then we can actually use this. So what we want to do is just return instances I. But before we do that, we need to do a few things with it. So we need to set it to active, so make that true. We also need to update its position and its rotation. So we're going to take its transform position, update that, and we're also going to update its rotation. And that should get us an object. We should be able to place it. The problem is this isn't necessarily going to work. Just for now, to avoid any complications with the rest of the logic, I'm actually going to simplify this. So while this is less than our instances.length, we'll increment our I, and then we can come back afterwards and actually fix all of this. So this, not optimal. We'll come back, actually use our last selected, and that should be good. But we can actually save that, like so. So set this equal to I. That way we're at least saving it. We're not using it yet, but it's there. And then one thing we do need to do is it's possible that all of the objects in the pool may have been created. So we could throw a new exception, or we could do really bad stuff. Like we could actually instantiate another copy, but if we do that, everything's going to break. So I'm not sure that's a good idea. We could throw, if we throw an exception, people have to catch it, and that's going to be slow. So I think the best way is to just return null and then make them have to handle that. So if it returns null, it couldn't create an instance. You need to handle that however you do it. And yeah, not sure that's a great solution. We'll tinker with it later. What else? Yeah, I think this is a good spot. We can actually start working with this. First off, I forgot to mention I had mapped the asteroid rings didn't look, or the ring shader didn't look like this before. I actually threw a texture on this from just some Saturn rings. It's done the exact same way as we're doing the density map. It's just I used an actual color texture and just applied it that way. It's still not done. That's I haven't figured out how we're gonna finish this yet. So we're gonna go back to this. I get distracted easily, it seems. So we need our instanced asteroid render, and we need to drop our prefab, and instead we want a generic object pool. So we're just going to take our pool like so, and then where is it? We've got our pool. That should be fine. And then we need to remove, we have a prefab we're instantiating here. Instead of doing this, we are going to do our pool.instantiate. I may not have made it public. I don't think I did. Ooh, that's a little bit funky. Let's make this public. Yeah, we'll need to do the destroy as well. So both of these will have to be public. Come back here. That should all go away. And then, so we've got that. The last thing we need is this destroy. We just need to do pool.destroy. And that should actually remove them. So we may still get null here, which we aren't handling yet. So the easy solution to that is to bump this up to something that we won't hit. I'm going to do 200, which might take a bit to spin up. We can tweak that later based on how many are actually created. And if we start getting null pointers, then we know something's wrong. I didn't have that activated. One sec. Let's actually enable our instance asteroid render and start this again. Or not. Are we actually, we didn't create any of them. Huh. So if it's not active, if itself is not active, that's weird. Why wouldn't that work? Active self, which should be correct, right? So if our instance is not active, then we want to make it active, set everything, and do all of that. The weird thing is it looks like we are doing that. Because we... Interesting. Very interesting. I'm going to drop a breakpoint here. Attach to Unity, actually inside of this. And this way we'll know if something is actually selected. If we hit that breakpoint, something else is broken. We've got other breakpoints here, so that's my bad. Yeah, we're not hitting that, so something funky is going on. Are we not instantiating things? What's going on? Oh, I know what's happening. We set everything up, but we never actually do that. We never actually assign it. So our entire array existed, but it was null. Now it's not. So this should work now. I say, hoping it actually does. So yeah, cool. So we've got actual asteroids. They're floating around. Assuming I did this right, okay. Something weird is causing this to crash. Because we shouldn't have been allocating anything. Nothing should have happened. Nothing. It's definitely not to do with the instantiation of objects. So Unity's broken. That's unfortunate. I think this is working though. We didn't have any errors. Everything seemed fine. I can't do a longer test without Unity working because we're just kind of constrained by that. There's nothing else I can do. So I don't know. It was amusing the first time it happened because it just kind of exploded on me for no reason. It's getting a little bit less amusing. So yeah, I think we have this pool. It's simple. It works. We don't need much. And we can kind of tweak it as we need. It's not going to dynamically increase or anything like that. If you used a array list or a linked list, instead of throwing null, you could actually expand the pool. We aren't doing that. We could, but it would be slower. Though, if you used an array list, the only slow part would be expanding the list. So, I don't know. You can play around with it and see what works for you or what doesn't. But I am still getting over a cold, so I think it's probably a good time to end. So, yeah, I think that's it. So if you guys have any suggestions or things you think we should try or change or anything like that, let me know. If you know how to fix the Unity issue, that would be fantastic because I really want to get this into Asteroids VR because I think we're at a point where we can actually just throw this in there and it will work, which would be really, really cool. I really want to do that. But other than that, I think we're good. So yeah, until next time, see you, Internet. So I got ahead of myself a bit. We hadn't actually finished. We have this last selected here, but we didn't actually use it. We should probably fix that because either we should take it out or we should actually do what I intended to do originally. So let's do that. Last selected. It's not well, actually. Here's what we can do. Let me undo all of this. Oops, too far. We're going to use this as an offset. So I don't know how good of an idea this is, but we're going to find out real quick. So we're going to have an index, because I and index are different things, obviously. And so we're going to take our last selected plus I plus 1. Yeah, that's definitely not going to confuse anybody. And then we're going to mod that by our instances.length. And so once I fix the funky formatting going on here, the way this works is this for loop, it's going to iterate over the entire array. It's going to go from 0 to whatever. What we're going to do is we're going to say we still want that many iterations, but we want to start with an offset. So that's what we're doing. We're providing an offset. It makes more sense if I do it like this. Our offset is the last selected plus 1, and then we're adding our iteration count. Then we're just taking the modulus so it wraps around. And then instead of using I here, we want to use index. So the index is the actual index that we're using, but I is just going to be used to actually count up through everything. So theoretically, if I did that correctly, it should find things better. I don't know why I didn't just do that initially, but the disadvantage is we add this extra int instead of doing some. We would have had to have done something funky in here anyway. So this is probably, it makes more sense, or at least I think it makes more sense. So yeah, we're gonna start there and see how that works. It should do exactly the same. We don't have enough objects being created and destroyed where we're cycling through yet. And I can't run this long enough where it becomes a problem. So yeah, here's everything we have. It all looks fine. I'm gonna stop that before it crashes. So everything's behaving exactly the same way. Just gonna turn on gizmos just to confirm that we were actually seeing real objects. We were seeing objects near the camera, so that pretty much has to be the case. I'm just confirming that's actually true. But the cool thing is you can actually see some of the collisions happening now. So it all works. I need to figure out what's causing the Unity crash. I think I might install just the beta, see if that fixes it. We'll see. I'm not particularly sure. So yeah, I think that's it for real this time. So we have a generic object pool. It's all good. But yeah, I'll put the code for the generic object pool down in the description because I imagine a few people are going to want that, and there's no point in rewriting it. It's basic. So there's also some really good walkthroughs by some people from Unity. So I'll put those in the description as well, because they go into a little bit more depth. They use pretty much the same style, but they approach it a different way. So if you want to see other people solving the same problem, check the description for links. But for real this time, see you, internet.